Hi, I'm Dr. Brett DePoyster with the Aquarium Vet, and in this video I'm going to go over the importance of pH in our aquariums. pH is probably the most important water quality parameter that we test for. And this is because of a variety of reasons, and one is the role that it plays in the toxicity of ammonia. As you might recall from our ammonia lesson, as the pH increases, the percentage of toxic ammonia, or NH3, shifts towards the left of the equation with a higher prevalence of toxic ammonia available. This is something that we need to consider when the water quality is off and you're attempting to fix the pH. We need to also check the levels of ammonia to prevent any possible ammonia toxicity events. Now, from my perspective as a veterinarian, I'm really interested in how pH directly impacts the health of the fish. pH changes can have a significant and direct impact on the metabolic pathways and acid-base balance of the fish. And if there's a sudden or significant change in the pH of the water, this can cause some major problems with these processes, leading to potential health concerns. This being said, species of fish have evolved to perform best at certain pHs. And if a fish is kept outside of their preferred range, this can have a negative impact on the overall health of the fish. As a very general guideline, here are some of the most popular groups of fish and their preferred pHs. Goldfish, gouramis, live bears such as guppies and platies typically prefer to have a neutral pH around 7 to 7.5, while many of the tetras and discus prefer a slightly more acidic pH around 6.5. And then there's the African cichlids, which prefer a more alkaline pH around 8.4. Although these are guidelines, I encourage you to research the species of fish that you're keeping and see where they're found in the wild and what specific water parameters are in their natural environment. For example, fish that are found in regions with lakes and streams with high carbonate rock and soil composed of limestone, such as those in Lake Malawi in Africa, will have a pH around 8 or higher. On the other end of the spectrum, regions that have acidic soils or large amounts of decaying vegetation producing humic and tannic acids will result in waterways with an acidic pH like that of the Amazon River. In these regions, the pH will drop even further after large rains and runoff, dropping the pH even further, and this can be a trigger for breeding of fish. The type of environment that the fish comes from should also be taken into consideration when mixing different species of fish in the aquarium. For example, discus should not be mixed with African cichlids. Now there's many reasons why this should not be done, but the emphasis here is due to the extreme differences in the preferred pH range. Now, in the ocean, the pH of marine water is usually between 8.1 and 8.3, and it is very stable due to the sheer volume of the sea, but also because of the buffering capacity of bicarbonate and borate systems that's present in the ocean. As a result of this stable pH, marine fish are much more sensitive to changes in pH compared to freshwater fish. And they're only comfortable in their stable pH range. Really, anything below 7.5 will result in long-term metabolic stress on those marine fish. Now that we know why pH is important, let's briefly shift to some chemistry. First, what exactly is pH? Well, pH is an acronym standing for the power of hydrogen. And what occurs in water is that the water molecule, H2O, can break down into H3O plus, or the hydronium ion, and OH minus, which is the hydroxyl ion. Technically, it's the hydronium ion that we're dealing with when we're talking about pH in aquariums, but this is generally simplified to the H plus, or the hydrogen ion. When measuring pH, we use a scale that runs between 0 and 14, with 7 considered a neutral pH. Anything less than 7 is considered acidic, and anything that has numbers above 7 is considered alkaline and has fewer hydrogen ions present while having more amount of hydroxyl ions in the solution. On a side note, but it is important terminology that can be confusing, is the word alkaline and alkalinity. Now, alkalinity is not the same as a high pH that is alkaline. Alkalinity refers to the buffering capacity of water, which is related to the levels of carbonate and bicarbonate, and I'm going to discuss this further in a separate lesson on water hardness. At a pH of 7, or the neutral pH, there are equal levels of hydrogen and hydroxyl ions present in the solution. Most species of freshwater fish that we keep tend to live in ranges between 6 and 8.5. Now certainly there's a few exceptions. For example, some of the Amazonian species that can tolerate much more acidic pHs, even as low as 5 or maybe even lower than that. In contrast, on the other end of the spectrum are some of the African cichlids from the Lake Tanganyika that can have a pH as high as 9.4. One of the other important points about pH is that the pH scale is a negative log scale. And so, when the pH gets lower, there are actually more hydrogen ions present. And because it's a log scale, this means that for every 1 unit of pH, it is 10 times the difference in the amount of hydrogen ions. So for example, if you measured a pH of 7, it has 10 times more hydrogen ions than a pH of 8. And a pH of 6 would have 100 times more hydrogen atoms than a pH of 8. This is a clinically or practically important concept to understand when keeping fish, because even subtle changes, say an increase from 6.8 to 7.8 during a water change, may not seem like a big jump, but it actually has a significant impact on the fish because of that logarithmic scale and the huge change in hydrogen ions that are present. When it comes to maintaining the pH in your aquarium, it's important to know that pH is constantly changing and it should be routinely monitored. You'll find that with time the pH drops, and this is due to several main reasons. The first is due to the chemical reactions that occur in the nitrogen cycle. The second is the carbon dioxide that's released by the fish during respiration. And the third main cause is fish waste, such as feces and other organic waste, such as uneaten food. Let's go through each of these 3 points in a little more detail. Recall from the nitrogen cycle lesson that the bacteria metabolizes ammonia and converts it to nitrite. When this occurs, the chemical pathways result in the production of hydrogen ions. So in our scenario of a closed aquarium, the biological filter is constantly producing large amounts of hydrogen ions, which then goes into the aquarium water and will reduce the pH. The second reason for a reduction in pH over time is the carbon dioxide that is excreted by the fish during respiration. The carbon dioxide reacts with the water to form a carbonic acid, which is a weak acid, and it will release hydrogen atoms into the water, lowering that pH. The impacts of carbon dioxide on pH can be reduced by providing airflow above the aquarium to remove excess CO2 and also degassing CO2 from the aquarium with the use of an air stone or breaking the surface of the water with the filter return. A simple technique to see if carbon dioxide is causing a low pH in the aquarium is to take a sample of water, measure the pH straight away, and then aerate the water with an air stone for about an hour. Then retest that pH. If the two recordings are identical, then it is unlikely that you have elevated carbon dioxide in the water. But if the pH is increased by say 0.1 or 0.2, then this might actually be due to excess CO2 in the water. The last main reason for a gradual decrease in the pH is fish waste and other organic wastes. This doesn't attribute as significantly compared to the first 2 reasons discussed. However, it can have an impact, and waste should be vacuumed or removed with regular maintenance to provide an overall good water quality parameters, including your pH. Now, I have already mentioned that sudden changes in pH can have an impact on the fish, particularly to that acid-base balance. So it's important that when we're adjusting the pH in the aquarium, if we're performing water changes, or if we're moving fish to a different aquarium, that they should be acclimated to that different pH very slowly. And in an ideal world, we don't want to change the pH by more than half a unit per day. This may not always be possible, but really we want to try to acclimate them as slowly as possible. If your pH is too low, the simplest way to correct this is to perform a water change with a water source that is more alkaline. And this might be adequate enough to control stable systems where pH reduction is really only attributed to the chemistry of that mature biological filter. When we're challenged with a persistent or low pH, first try that aeration bucket trick that I mentioned earlier to rule out carbon dioxide as a potential source of low pH. This can then be corrected with that surface agitation and improved airflow. Even opening a window or turning on a fan can help. pH can also be increased with the use of chemicals and buffers that are readily available at a local pet store or aquarium shop. Most commonly, these products are made up of a sodium bicarbonate and also a sodium carbonate, or a mixture of the two. Sodium bicarbonate is a quite safe product, and it'll increase the pH, and it works by partially dissociating into carbonate and hydrogen ions. So when added to the aquarium, this increases the amount of bicarb and carbonate in the aquarium. To get a little technical, this might initially cause a slight drop in pH due to the hydrogen ions, but in the long term, it will buffer and increase the pH because of the increased amount of carbonate and bicarbonate. As a general guideline, to increase the pH by 0.1 unit, add about 2 to 3 grams of sodium bicarbonate per 100 liters of water. Sodium carbonate will also increase the pH because much of the carbonate combines with the free hydrogen atoms to form a bicarbonate, resulting in increased pH. Sodium carbonate can be used at a dose of 0.4 grams per 100 liters, and it is common to use a mix of sodium bicarbonate and sodium carbonate to maintain the pH. So make sure you follow the instructions or the directions on the product that you've purchased from your local aquarium shop. Decreasing the pH is generally not required unless the water source is alkaline, or dropping the pH is required to stimulate some species of fish like discus to breed. In scenarios where the pH is too high, first investigate why the pH is high to begin with. Is the water source too high to begin with, or is there something in the aquarium that's buffering the water? For example, limestone-based rocks or shells from the beach might be used as decorations in freshwater aquariums. This will buffer the water, and they will need to be removed in order to lower the pH. For species that prefer lower pH, like many of the Amazonian tetras or discus, the most common method is the use of peat moss or peat moss extracts that are added to the aquarium or to the filter of the aquarium. This works by adding humic and tannic acids to the water, reducing the pH. So that covers an introduction to pH and its role in the aquariums. The take-home message is to measure and monitor pH regularly, ensure that the pH matches the natural environment of the species of fish that you're keeping, and adjust the pH as slowly as possible when you're acclimating fish or correcting the pH. Follow these guidelines and your fish will thank you for it. I'll see you in the next lesson.